Imagine parking your car and a little beep tells you, stop, you're too close to the wall. Or think about a smart bin that can sense when it's full and automatically alerts the city's cleaning service. Pretty cool, right? Well, at the heart of these systems is a tiny but powerful device called the ultrasonic sensor. And today, we are going to learn how it works and even build a mini project with it using Arduino and Tinkercad. So, what exactly is an ultrasonic sensor? Think of it like an electronic bat. Bats fly in the dark by sending out sound waves and listening back for echoes to know how far objects are. The ultrasonic sensors works the same way. It sends out sound waves we can't hear, waits for them to bounce back, and then calculates how far away an object is. You will find them in car parking systems, automated doors, smart bins in cities, and even in robots that avoid obstacles. Here's how it works. The working principle of the ultrasonic sensor is very simple. The sensor has two parts, a transmitter that sends sound waves and a receiver that listens for the echo. If an object is close, the echo comes back quickly. If it's far, it takes longer. Using the speed of sound, we calculate the distance with this formula. Distance equal to speed of sound into time divided by 2. In other words, the quicker the echo, the closer the object. Simple but super powerful. To try this out, we just need a few parts. An Arduino UNO, an ultrasonic sensor, a breadboard and a jumper wire, and then to make it more fun, we'll add a red LED to act as an alert light. Let's build this in Tinkercad, for which we need an Arduino UNO board, an HCSL04 ultrasonic sensor, in red LED light, a resistor, and jumper wires, and finally a breadboard for the connection. Connect the VCC to the 5 volts in the Arduino UNO board, the GND to ground in the UNO board, trigger pin to Arduino pin 12, echo pin to pin 13, and our LED to pin 8 with a resistor. So now when the sensor detects something too close, the LED will glow just like a mini parking sensor. Here's the code all work that makes it all work. First, we set up the trigger, echo and LED pins. In the loop, the Arduino sends out a short sound pulse. The sensor waits for the echo, measures how long it took, and converts the time into distance. Then we print the distance in centimeters on the serial monitor. And finally, the fun part. If the object is less than 20 centimeters away, the LED lights up as a warning. It's like giving your Arduino a pair of visible eyes. Let's test it now. I'll start the simulation. Here you can see the distance value updating in the serial monitor. Now, as I move the object closer, watch what happens. The LED turns on once the object is within 20 centimeter, and when I move it back, the LED switches off. This is exactly how your car knows when you're about to hit something while reversing. And that's it. We just built a working distance measurement system with an ultrasonic sensor and Arduino. Small components but big possibilities. You can use it in smart bins, robots, security systems, or even your own DIY parking sensor. In the next video, we'll switch gears and have some fun simulating a traffic light system using LEDs and Arduino. So stick around and let's keep exploring IoT together.